Welcome to GWA Physics, and the problem that we're going to look at here today is second class levers. Now, like first class levers, it has a special mechanical advantage. It says that the mechanical advantage of the lever arm for the effort and the lever arm for the resistance. But where most of the students fell short on this was the idea of making sure that they measured those properly. Now, the definition for lever arm is the distance from the fulcrum to where the force is applied. So if we look at this problem right here, the fulcrum is down on one end. And so we're measuring from the fulcrum to where the force is applied, and we're measuring from the fulcrum to where the force is applied. So in this distance right here, from 70 to 90 is just a lever arm of 20. So the resistant force has a lever arm of 20. But then the lever arm for the effort goes from the fulcrum all the way down to where the spring scale is attached. And from 90 to 10 is a value of 80 centimeters. So you've got a lever arm for the effort at 80, and you've got a lever arm for the resistance of 20. Now, when you plug those numbers in right over here, you've got 80 over 20, which you can see is automatically a mechanical advantage of 4. Now, that means that the mechanical advantage is 4 here, and it also means that the mechanical advantage is 4 here. The mechanical advantage, all three equations, the mechanical advantage is the same for that particular problem. Now, if we have a 10 Newton object here, and we're trying to find out what the force is going to be read on the spring scale, we're going to take this first equation, and we know that the effort or the resistant force is 10 newtons, but we do not know what the effort force is or what the spring scale is going to read ahead of time. So doing the algebra, you've got, you cross multiply like this, and you've got 4x on the right is equal to 10, and x equals 2.5 newtons. So the spring scale is going to read 2.5 newtons right there as we're pulling up on it. Secondly, let's switch it up a little bit. Let's suppose that I'm going to pull up on the spring scale 12 centimeters. If I move the spring scale 12 centimeters, how far will the object move based on the mechanical advantage? So over here in this problem, let me rewrite it over here. We've got 4 over 1 is equal to 12 over x. So when we cross multiply, we're going to get 4x on this side, and we're going to get 12 on this side. When we divide by 4, x equals 3 centimeters. So in order to lift this object 3 centimeters, we're having to pull on the handle over here 12, which is a mechanical advantage of 4. Likewise, in order to lift a 10 Newton object, we're only having to apply a force of 2.5 newtons because that is a fourth of the weight that we're trying to lift with that second class lever. If you have any questions, please contact me. And thank you for watching.